Okay, so now for this unit, we're going to be talking a lot about triangles, but we need to get some background information before we start. There's going to be a lot of definitions, so we're going to go through them really slowly and kind of pick apart what they're saying. Okay, so the first definition we need to talk about is a point. Now, point is a location and is named by a capital letter. So what you'll see is you'll actually see like a big fat dot with a capital letter next to it. And you say it as point M, and this is how you write it. You write point M. Some people literally put a point and then write the letter. The next definition is line. A line is made up of points. It has no thickness or width and is named by 2 points on the line or a cursive letter right next to the line. So this is what the picture would look like. And you see I've got 2 points on my line. So I can name that by the 2 points, and it can be any 2 points on that line, and it's got this little line above it, and we've got 2 arrows on the end because both of these ends go on forever and ever. They're infinite. Also, do you notice this little lowercase cursive letter located by the line? So another way to label it is write line and then lower cursive letter M, or whatever letter's next to it. The next thing we need to talk about is a segment. Now, a segment is just a piece of a line. It's got 2 definite endpoints, and we name it by the endpoints. So on this one, my 2 endpoints are K and L. So I literally write KL, but notice how this time I have a line above my K and L, but it does not have arrows because it has 2 definite endpoints. So that is point, line, and segment. The next one we're going to talk about is a ray. A ray is also a piece of a line, but this one actually has 1 definite end and 1 infinite end. So here's the definite end. It means that it actually ends there. And then 1 infinite end means that it goes on and on and on forever to the left. It's named by the endpoint, in which you always put the endpoint first, and another point on the ray, and it doesn't matter what other point you pick. But all that matters whenever you're labeling rays is that your first thing that you name is the endpoint. So this one, my endpoint is P. That's why it's listed first right here. So we have ray PQ, and notice how above this one we actually have an endpoint and an infinite end. So that is ray PQ. The next thing we're going to talk about is angles. An angle is composed of 2 sides and a vertex. Now, the vertex is the point where the 2 sides intersect. Now, the sides can be rays, segments, or lines. In this particular example that I have drawn, I actually have 2 rays because they have the same definite endpoint, which is M, and they have infinite ends. So there's actually 3 ways to name angles. The first way is a number. Sometimes you'll see a little number written beside the vertex. So I've got number 3 here, and we use this little symbol. It kind of looks like a less than symbol, but the bottom is, it goes, it's flat. It's not angled. Like if this is, if this is a less than sign, this would be an angle sign. It's just kind of tilted. So we have the angle symbol and the number 3. The next way you name it is sometimes if there's only 1 angle dealing with your letter, you can name it by the vertex. Now, if you had a couple of different angles coming off the same vertex, it would be very hard to distinguish which angle you're talking about if you named it by the vertex. So, but this is still another way to name an angle. The vertex right here is M. That's where our 2 pieces intersect. And you'd use the same angle sign and then the letter M. And the last way, and number 3 is the most common way because it states clearly what you're talking about. You name it by 3 points. Now, the biggest part about this is that the vertex is in the middle, and that's the biggest mistake I see when people label angles. So the vertex, which is M, is in the middle. That's why we see M in the middle here. Now, we can name that LMN, or we can name it NML. It does not matter as long as your vertex is in the middle. So the third way that we name the angles is the most common, and it's also the safest. Now, types of angles, I'm sure you've seen these before. The first type is acute. That's when you have an angle that measures less than 90 degrees. And don't forget that little circle up top means degrees. The next one is obtuse, which means that the measurement of our angle is greater than 90 degrees. And the third type of angle is right. That's one that's exactly 90 degrees. Now, on a picture, sometimes you'll see something like this. Now, it says that if you see this little box right here, that's telling us that that measurement is 90 degrees. So the next thing we're going to talk about is a midpoint. You've heard midpoint algebraically. You found midpoints on the coordinate plane. But let's talk about a midpoint of a segment. It's a specific point on a segment that creates two congruent, and notice the symbol for congruent is right here. It creates two congruent smaller segments. Now, on this particular example that I have drawn, point Q is the midpoint. And because point Q is the midpoint, we can say that this segment, PQ, is congruent to this segment, QR. So this is what that statement reads. Segment PQ is congruent to segment QR. Now, if you notice, they've got these little thingies, little tick marks on them. Because they have the same number of tick marks on them, by looking at the picture without knowing anything, not even knowing that Q is a midpoint, you can say that those two segments are congruent. And another thing you need to know is that the length of PQ and QR is exactly half of PR, because you're cutting it in half, so that means that the measurement of PQ is half the measurement of PR. Okay, so let's talk about adjacent angles. Adjacent angles are two angles that share a side and a vertex. So a side can be a segment, a ray, or a line, but the biggest thing is they share a vertex. And a vertex, remember, is it's like the corner of the angle. It's where the two sides intersect for the particular angle. So the side that they share is right here in the middle. We have ray BC that's shared, and also the vertex that's shared is B. So angle DBC, so we're talking about this angle right here, DBC, is adjacent to angle CBA, which is this angle right here. So those two angles are adjacent. The next type of angle relationship we're going to talk about is vertical angles. Vertical angles are extremely useful. Now, they're two angles that are across from each other at an intersection. So, if you look at our picture, it says 1 and 3 are, that should not say adjacent, it should say vertical. Let me fix that. Okay, got that fixed. Sorry about that. It says angle 1 and angle 3 are vertical. So these are across from each other at an intersection. So these two angles are vertical. And also, whenever you have an intersection, you have two sets of vertical angles. So 2 and 4 are also a set of vertical angles. Now, this is something that's really important and used a whole lot in this unit and in the future. Now, there's something that says, it's actually a theorem. We're going to talk about the definition of what a theorem is. It says that adjacent angles are always congruent. So, based on this statement, we know that angle 1 and angle 3 are congruent, and also that angle 2 and angle 4 are congruent. Okay, so let's talk about complementary angles. Complementary angles are two angles whose measures add to 90 degrees. They can be adjacent, but they don't have to be. Now, I've got a set that are adjacent, which is this set right here, and I also have a set drawn that are not adjacent, which is right there. So, now remember, when we had this little box, that meant that we had 90 degrees. So, angle 1 and angle 2 are complementary, because if you add them together, you would get 90 degrees. And this extra set over here, we have 50 and 40, which when you add together, you get 90. So angle 3 and angle 4 are also complementary, but they are not adjacent. So complementary, it doesn't matter if they're adjacent or not. Now supplementary, we have two angles whose measures add to 180 degrees. Now these can be adjacent, but they don't have to be, much like complementary. So I've got a first set that is adjacent. So angle 1 and angle 2 are 180 degrees. And the reason why you know that is this bottom line down here, it's straight. So even though we don't have measurements marked for 1 and 2, we know that they have to be supplementary because they back up to a straight line, which if you measured the degree from here to here, we would get 180 degrees. So angle 1 and angle 2 add to 180 degrees. Then, if you look at this other set that are not adjacent, we have them marked 180. So 100 plus 80 is 180. So angle 3 and angle 4 are supplementary. So the measure of angle 3 plus the measure of angle 4 is 180. Now, a lot of people get these mixed up. So I'm going to try to give you a little helpful hint. So complementary starts with a C. So if you say complementary, we have C, and I'm going to put a 90 in the middle of it. Now, this might be a little silly to you, but it helps some people. Now, supplementary is an S. We've got two little holes to put things in. So that's 90 and 90, and 90 and 90 add to 180. So complementary, they sum to 90. Supplementary, they sum to 180. Now, the last definition we're going to talk about is a specific type of supplementary angle. It's called a linear pair. A linear pair is supplementary angles that are adjacent. So not only are these supplementary, but they're also adjacent. So if you have these two things together, you have what's called a linear pair. So angle 5 and angle 6, form a linear pair. So you need to make note cards with all of these definitions on them. Everything that's written on these slides you need to write as well. You need to put a picture to go with it. And you need to make sure you know these in the future.